Now, let's try to solve for the characteristic equation of a 3 by 3 matrix. We have two matrix A here, which are again considered to be a 3 by 3 square matrix. This characteristic equation is essential in solving for eigenvalues, eigenvectors, and the corresponding eigenspaces. In order for us to solve for the specific characteristic equation, we need to come up with this matrix form. It will have a certain lambda. In this case, it is a variable because the lambda that we're going to solve after we're done with characteristic equation is the eigenvalue. So in this case, first it's a variable times I, the identity matrix, minus A, which is your specific matrix A here. Now, after we are done with that, we are going to show the determinant of said matrix, and then the determinant will automatically tell us the characteristic polynomial. When we equate the determinant to 0, that is then the characteristic equation of the specific matrix A. But before we proceed with this expression, we have a certain I here as mentioned. This is an identity matrix. This identity matrix is pertaining on the size of 3 by 3. So since both matrices A here are 3 by 3 square matrix, our identity matrix is also a 3 by 3 square matrix. We have 1, 0, 0, 0, 1, 1, 0, 0, 1. So let's start now with the first given matrix. So we'll have lambda again times your identity 1, 0, 0, 0, 1, 0, 0, 0, 1, okay, minus your matrix A 2, 0, 1, 0, 3, 4, 0, 0, and 1. Let's simply multiply first the lambda. You have lambda 0, 0, 0, lambda 0, 0, 0, lambda, minus the same 2, 0, 1, 0, 3, 4, 0, 0, 1. Then, since both matrices are 3 by 3 matrices, so the difference is defined. The first entry is lambda minus 2. So we have lambda minus 2. Next entry is 0 minus 0, 0. 0 minus 1, negative 1. Okay? Next, 0 minus 0, also another 0 here. Lambda minus 3. So you have lambda minus 3. Then, we have 0 minus 4, negative 4. Next, 0 minus 0, 0. 0 minus 0, another 0. And finally, lambda minus 1. Okay? So, this is now the matrix that is formed by this expression. Next thing here is again to solve for the determinant of this. So let's move it here and then use the spaces. Since our matrix here is a 3 by 3 matrix, we cannot use the AD minus B because the AD minus B only works for a 2 by 2 square matrix. Now, you can of course apply here the concept of cofactors and all other process in solving for the determinant, but let's just use here the what they call this one, the most original, the basic form of the determinant. So you will are going to multiply this. So you will move from here to there, and here to here, here to here as well. Then you move on the other side, but all of the product from upper right to lower left would become minus or negative. So our first is lambda minus 2 times lambda minus 3 times lambda minus 1. Okay, that's the first. Next is 0 times negative 4 times 0, so you have plus 0. Then negative 1 times 0 times 0, so plus 0. Minus the next entries. we have negative 1 times lambda minus 3 times 0, so you have 0. Negative 4 times 0 times lambda minus 2 is another 0. Lambda minus 1 times 0 is also 0. In short, the determinant for this expression is the product of lambda minus 2, lambda minus 3, and lambda minus 1. Of course, if we're going to multiply this 3, this is your characteristic polynomial. But since the goal of characteristic polynomial and equation is to solve for the lambda, let's just stick with this. And when we equate this entire expression to 0, this is now your characteristic equation, which will be used in solving for the values of lambda, which corresponds to our eigenvalues of the first matrix A. Okay, so let's duplicate the same process, as we are also going to use this expression here. So you will have lambda times identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 minus negative 5, 0, 0, 3, 7, 0, 4, negative 2, 3. Right. So you will have here matrix lambda 0, 0, 0, lambda 0, 0, 0, lambda minus this is lambda, okay, minus negative 5, 0, 0, 3, 7, 0, 4, negative 2, 3. Okay, and then the difference is defined. You will have lambda minus negative 5, so lambda plus 5. Again, minus negative 5. So 0 minus 0, 0 minus 0. 0 minus 3 is negative 3. Lambda minus 7 here. Then 0 minus 0 is also 0. And then 0 minus 4, negative 4. 0 minus negative 2 is positive 2. And then lambda minus 3. This is now our matrix for this expression here, this one, and let's solve for the determinant. Of course, this has the same concept with the first. We cannot use the AD minus BC. And of course, notice here, okay, in your first form here, you have this is a upper triangular matrix. Hence, the determinant is the product of the entries on the main diagonal. Okay, that's a theorem in our previous lessons. This is now a lower triangular matrix, and of course the product or determinant is just the product of the entries on our diagonal. But of course, just for the purpose of discussion, simply continue here. So you will have lambda plus 5 times lambda minus 7 times lambda minus 3. Then this here plus 0 and here plus 0. You are seeing this one here including the next items because again we have triangular matrices here. So this is 0 plus 0 plus another 0. Hence again the characteristic polynomial is we have lambda plus 5 times lambda minus 7 times lambda minus 3. And its equation without multiplying this, so that we will have an easier forms on our process in solving for the eigenvalues to be provided in the next videos. Okay, and we'll be using these results in our next videos. This is now our characteristic equation, similar to earlier. So the characteristic equation will be used in solving for the eigenvalues, and there were results of the determinant of this entire expression here using the correct identity matrix following the size of the given matrices and the correct operations involving matrices. So thank you very much for watching.